Hi, this is Mr. Singh here. Today's lesson is on the motor effect, which is part of the AQA physics syllabus. Before we start, quick retrieval, 3 questions. Pause the video here and have a go, please. Okay, so let's have a look. Number 1, what are the 2 poles of a magnet? 2 poles are north and south. Number 2, what is an electromagnet? I should say, not electromagnets. A soft metal core made into a magnet by the passage of electric current through a coil surrounding it. And the perfect example where electromagnets are used is in a scrapyard. There are many other examples also. Number 3, how can you increase the strength of an electromagnet? Well, you can add more turns to the coil, or you can increase the current flowing through the coil. So, moving on. The motor effect, 3 objectives. And the keywords core, direct current, magnetic field, split ring commutator. What I would highly recommend you do is, before we move into this is the time. You need to watch videos on YouTube channel on the motor effect. There are quite a few, but you need to select one, and I would highly recommend you watch a short video on the motor effect that are on YouTube channel. So once you've done that, once you've watched the video, let's move on then. So a simple direct current electric motor and how it works. Now before we do that, 3 little blue boxes below. Don't forget, direct current flows in one direction only. Fleming's left-hand rule, you will have done that. It can be used to find the direction of each force. And the third one, I will come back to in a bit. So, what is the motor effect? Well, the motor effect is when a current carrying an when a current carrying wire experiences a force in a magnetic field. So if you have a wire that's carrying an electric current, pass the wire through a magnetic field, and the wire experiences a force. So here we go. You can see in the picture a loop of wire that is free to rotate about an axis is placed in a magnetic field. When direct current flows through the loop, the side arms, which are at 90 degrees to the field, experience a force due to the motor effect. They experience forces in opposite directions because the direction of the current in each arm is opposite. The loop will start to rotate around its axis because the forces act one up and one down. You can clearly see the direction of the current there, and it's in the opposite direction there. And then when the wire loop reaches a vertical position, the forces will still be acting one up and one down on the same arm of the loop, so the loop gets stuck. Now then, for the motor to keep rotating in the same direction, the forces acting on the arm of the loop need to swap directions. That's the key. We need to somehow find a way of swapping directions. And this is the point I was talking to before. I said I'll mention it again. The loop will actually vibrate back and forth slightly as it'll have some momentum. So let's have a look at this, swapping direction. Well, reversing the direction of the current reverses the direction of the force. So, that's what we need to do. We need to reverse the direction of the current. A split ring commutator is a clever way of doing this. It swaps the contacts of the loop every half term, reversing the current. And you can see that in the picture, and hopefully you saw that in the video, in one of the YouTube videos that I recommended you watch. A split ring commutator is just a conducting ring with a gap between the two halves. As it rotates, the part of the commutator that is touching each contact changes every half turn. By linking each end of the loop to one half of a split ring commutator, you can change the electrical contacts of the loop and so the direction of the current every half turn. This means that the force acting on each arm of the loop will swap every half turn, allowing rotation to continue in the same direction. So, how can we change the speed of a simple electric motor? Well, we can change the speed in two ways. You can either increase the current or increase the strength of the magnetic field. Both these factors increase the force experienced by the wire due to the motor effect, so it rotates faster. Using a coil of wire instead of a single loop will also increase the force caused by the motor effect. So instead of a single loop, they can use a coil. And the direction of the simple motor, well, the direction of the motor turns can be found using Fleming's left-hand rule. And in the picture, you can see Fleming's left-hand rule. And it can be reversed by either swapping the polarity of the direct current or swapping the magnetic poles over. The next thing we need to look at is a loudspeaker. There you go. So, loudspeakers work due to the motor effect. Now, loudspeakers and headphones, which are just tiny loudspeakers, really, headphones, both use electromagnets. So, an alternating current is sent through a coil of wire attached to the base of a paper cone, and you can see that in the picture. The coil surrounds one pole of a permanent magnet and is surrounded by the other pole, so the current causes a force on the coil, which causes the coil to move. When the current reverses, the force acts on the opposite direction, which causes the cone to move in the opposite direction too. So variations in the current make the cone vibrate. And if the cone vibrates, this makes the air around the cone vibrate and creates a variation in air pressure that forms a sound wave. The frequency of the sound wave produced is the same as the frequency of the alternating current. So by controlling the frequency of the alternating current, you can alter the sound wave. Progress chat. Here's some questions for you. Pause the video here and have a go at these, please. Okay, let's have a look at the answers then. There you go. Number one, it reverses the direction of the current every half turn, so that the force on each arm of the loop of the wire loop changes direction every half turn. This way, the force is always acting in a direction that causes the coil to keep rotating. And number two, by swapping the polarity of the direct current supply or swapping the magnetic poles over. Number three, about the loudspeaker. And then the application questions, A, anti-clockwise, B, it will increase, and C, the direction of the rotation will be reversed. So make your way past questions. When there is a current in a coil, the coil rotates continuously. You can see that in the picture. Explain why. This will be worth a few marks. Okay, let's have a look. So, 1 mark. The sides of the coil experience a force. The force causes moments that act in the same direction, or you can say the moments cause the coil to rotate. 2nd mark. After each revolution, the two halves of the rotating commutator swap from one brush to the other. 3rd mark. And then the final mark, the commutator reverses the current. And that concludes our lesson today on the motor effect.